for loops and our continue and break statements. And these statements will work in while loops as well, or just any loop in general. We're going to start off with our test.lime file. I just have a main function in here set up. We have a variable set to 0. That'll be A. We're going to be implementing a very basic and generic for loop. So I equals 0, the condition, while I is less than 10, and then every iteration will add 1 to I. If it's 5, we're going to break early and it's not going to print 5. It will just break out of this for loop entirely and go to our return statement. If it's neither of those, we're going to print I, and then we're going to set A to I for funsies just to have something else down here to return. That's basically all. This is our goal for the episode, and it's pretty self-explanatory, and let's go. So first thing, like always, token.py. We're going to be adding in 3 new token types. For our new keywords, we have continue equals continue, break equals break, and for equals for. Now down in our regular keywords, we're going to add 3 new keywords like we just added the types for. So our break is going to be mapped to break, continue, for. Now in our Gen Z safe keywords, I have 3 just for fun. We have yeet for breaking, so we want to yeet out of that loop. We have another one for continue, so we just want to go to another iteration. And then we're going to dab for the for loop, because why not? That's all we need to do for our token.py, so we'll Control S, save that. We'll go into our AST now. We can skip the lexer. So AST.py. We're going to first start with our node types. We're going to add 3 more statement node types. 1 for the break statement, 1 for continue statement, and 1 for for statement. And then we'll go down to the bottom of our statements section or region. And I'm going to start with the break statement. So I'll paste that in for the sake of time. Break statement, going to take in nothing, do nothing other than return that this is a break statement. Same thing for the continue statement. You can pretty much copy paste and change this to say continue, and continue statement here. Continue statement is not going to have anything special we need to do with. We just need to know that, hey, there is a continue statement here. And finally, slightly more involved node will be our for node, for statement. It's going to take in a variable declaration. So I'll get our test.lime file down here at the bottom for us to take a look at. So we have our for, so here's our variable declaration, which is just a let statement. We have our condition, which is an expression. So I less than 10 is our condition expression. Then we have an action. So what we want to do every single iteration of the loop. Right now I have this set to an assign statement. We'll make this more generic into an expression later in the series, but right now we're expecting an assign statement right here to assign I to something every iteration. Then of course we have our loop body, which is our block statement. And we'll set all those variables up. Then normal type function and JSON function. And we'll just set every variable as a key value pair in our dictionary. We'll save our ast.py and we'll move on into our parser. First thing we'll do is import our 3 statements. So break, continue, and for statements. We'll import those. We need to go down to our parse statement method. Down here below parse program, I have it in our match case. We need to add 3 more cases. For the sake of time, I will paste these in. So we have our break. So it's going to go to a parse break statement. Continue, parse continue, for, parse for. The first thing that we will implement, or we'll define all these functions first. So we'll start with our break statement. We'll go down to the bottom of our statement methods region. Def parse break statement, self, we'll take in a break statement. All we're going to do is advance the parser past that break keyword and then return a break statement node. Our continue statement is exactly the same, except we're returning continue statement nodes. And then below that, we'll start with our parse for statement. Take in self. For statement is the return type. We'll go ahead and set up our for statement node here. So we'll initialize a new object. First thing, once we hit this for keyword, the next token that we're expecting is a left parentheses. So if not self.expectPeak, token type dot left paren, we're going to return none. Next thing we're expecting is our let token. So if not self._expectPeak, token type dot left paren, return none. Now the reason we're doing let. The reason we're doing an expect peak for the let is because that we know from our AST that we're expecting a let statement, so we want to verify that we're going to actually have a let statement to parse. So once we have that verified, we can set the for statements var declaration property equal to self.__ parse let statement. So that's going to parse this whole statement right here before the semicolon, of course. Now we need to skip the semicolon. So I'll skip semicolon. So now we're here on this I. So now we're expecting a condition. So statement.condition. And that condition is always going to be a expression. So we'll use our parse expression function with the lowest precedence type. After this expression, we're going to be expecting a semicolon here. So I'll paste this in for the sake of time. We can also, might as well go up here and expect it as well up here. So expect token type semicolon after the let statement, expect it again after the expression for our condition. And now we are expecting an assignment statement. So statement.action is self.parse assignment statement. Now after this assignment statement is done, we're going to be expecting, we may have to come back to this, but we're going to be expecting a left brace. So I'm going to put this here, but take this with a grain of salt because I'm not sure where this parenthesis is going to be consumed at. So just right now we'll put this here. We may come back to it. But after we've verified that there is a left brace, we're going to do statement dot, if I can type, statement.body is we're expecting a block statement. So we're going to parse a block statement. And then we have our for loop fully parsed, so we'll return back that for statement we have been building out in this whole function. So now all three of those functions are implemented. The last thing we have to do is implement the compiler for it. So in our imports, we'll import break, continue, and for. We are going to go down to, in our init function of the compiler, underneath initialize built-ins, we need to keep references of where our breakpoints and continues are for during the code so we know when to break out in some of our functions. So self.breakpoints, it's going to be a list of blocks, IR blocks, and then we'll have a self.continues is another list of IR blocks. We'll set those to empty list to start. Now we'll put a little comment here just for fun's sake. Now we can scroll down to our compile method in our match case. In our statements section, we can add our three cases, our break, continue, and for. In the visit functions for each, we can go ahead and type those out or call those right now before we implement them. Now we'll go to the bottom of our visit methods statements underneath the while statement we did last episode. And I'll go ahead and paste in our break statement and our continue. So we take in nodes, but we don't really use them. And all we're doing is branching to this specific block that was the last added breakpoint. That's all we're doing, is branching to that block on both of these. So for continues and breakpoints. For our for statement, we'll do def underscore underscore visit for statement self, and then we'll take in that for statement node. Since this one's going to be a lot more involved, we'll go ahead and declare out some variables to break up our node class. Var declaration, condition, action, and body. We need to create a new environment specifically for this for statement. So we're going to save the current environment we're in to a variable. Then we're going to create a new environment where the parent is that previous one. So we're going to create a child environment for those for statement block specifically. And then we're going to first compile the let statement. So var declaration. We need to create two blocks for this for statement. One's going to be the entry into the for statement, and one's going to be otherwise. So when that condition up here resolves to false, it will go to the otherwise, and if it's still true, it'll loop back to the entry block and run the code again. So for loop entry, almost exactly the same as our while loop. Self.builder.append basic block. We'll do a format string in here, for loop entry underscore. We'll use our increment counter function. And now for our for loop otherwise, do the same thing. Self.builder, append basic block, f-string, for loop otherwise underscore, and we'll do our counter variable since we incremented it in the first one. Now we need to keep track of our breakpoints in our continues block. So if we happen to use a break or a continue, the code can, or our visit statements up here can then get that block, since it's going to be the last one that we added, and then branch to that block. So self.breakpoints.append for loop otherwise. So if we do hit a breakpoint, we want to go to the otherwise block because we're leaving the for loop. For continues, self.continues append, we're going to put the entry block, because if we use a continue, we want to go back to the start of the for loop and evaluate the condition. Now we'll branch off with the builder, self.builder.branch. We'll branch to the entry block of the for loop. We're going to position at have our builder positioned at the start of that entry block. So for loop entry. And now that we're in the entry block, we're going to compile the body. Then we're going to compile the action. Then we're going to resolve or test the condition expression to see if it's true or false. So test underscore equals self dot resolve value. We're going to pass in our condition expression. Now, similar to the while loop, we're going to do a self.builder.c branch, so a condition branch. The condition is test. If it's true, we want to branch off and go back to the entry block. If it's false, we want to go to the otherwise. Now, once the for loop is finished, we want to set our position, builder's position at the start of the otherwise block. And then our for loop is finally compiled, so we can get rid of our breakpoints. So we'll go ahead and pop our breakpoints list and our continues list. We'll just pop what we appended earlier right here, and we'll just get rid of them. So we'll take them off. And then that should be everything for our for loops and continues and breaks. So we'll go ahead and do our python main.py. Now this is probably the issue that I was pointing out in the parser. We may have to come. Okay, so in the parser, I added some expect peaks functions for semicolons. What we really need to do is make sure your parse for statement looks like this. So we're expecting left paren, then expecting let, parsing the let statement, then we're going to use the next token function to skip the semicolon, parse the condition, make sure that the next one is a semicolon. Now we're going to skip the semicolon again with next token, and then go into the assignment statement. And then we have one more issue here with the continues. Now I'm having a little trouble. Something must have changed with my LLVM Lite since I wrote this code. So for right now, I will come back later and implement the continue block. So we'll go ahead and take that out for now. We'll come back to that. I'll make sure to put on my Discord if I find my solution, or if you guys can blatantly see it, please let me know on my Discord. The link will be in the description. But we should be able to do python.main.py, and here we are. So goes all the way, prints to 4, and then it breaks out perfectly, and the program still returns 4. So alright, so for loops and break statements are implemented. The continue statement is majority implemented. There is a issue in the compiler for it, but if I find a solution, I will post it in the Discord or make an updated video as well. But thank you guys for watching. The next episode is going to be on prefix operators. So we're going to be able to finally do negative numbers and be able to go like not true. So thank you guys for watching, and I will see you in episode 14.